Okay, midpoint can be thought of based on the picture of how we're going to get there. Okay, but once again, a lot of names that we have in geometry are pretty straightforward. If I say the midpoint, then it is the point that is in the middle of a segment. Okay, it's going to split it in half. So if I were to draw a picture of a midpoint here, I would say M is the midpoint. Well, how do I know it's the midpoint? Well, because it's in the middle, okay? And we can't just tell by looking, so I need to have some type of marking there to show me that it is in the middle, and that's where the markings that we talked about yesterday are going to come into play. If I see those markings there, I know that that is the midpoint. And that kind of brings up a good point of, if I give you a picture like this and I say, is M in the middle? Yeah, we don't really know, okay? Like, it could be, right? But there has to be something there that kind of tells us that or shows us that. Either that could be a statement that says M is the midpoint. It could be a marking that says these are congruent, so M must be the halfway point of that segment. But we can't just tell by looking, okay? Sometimes in geometry, that kind of throws us off because it looks like it could be the midpoint, but here we just don't have any way of proving that it's the midpoint, okay? So we got to have some piece of information that gets us there. I also, using what we talked about yesterday, can make the statement that AM equals MB. And what am I saying when I say AM with nothing, no symbol above it? It's what? It's what?
What was the question?
Yeah, what is AM or MB with no symbol?
It's not congruent.
Nope. Yeah. Nope. Not a line. Line. Plane is 3 letters, so that's why it can't be a plane. A line would have a line symbol above it. We talked about this yesterday. We said if there's no symbol above, it's the length. It's talking about the length. So here we're saying the length between A and M is the same as the length between M and B, okay? Or the distance, however you want to say it, length or distance. Okay? So obviously that's something we got to pay attention to because already one day later we're kind of we're going to see that written out and we got to know what that means. If it just says find MB, then what does that mean? Well, it means find the length of MB or the length or distance from M to B, however you want to say that. So that's something you got to really pay attention to. All right. On this segment bisector here, if I were to draw a picture here, if I give you a segment, I could split that segment into 2 parts, okay? But in order for them to be equal parts, then we would have to know that it's through the middle of that segment. And there's lots of different things that could do that. We could put a point right here. And once again, in order for this to be true, we would need to know that it goes through the middle, or it's at the middle. In this case, since it's a point. Both AM and BM are congruent. Okay, so it could be a point. It could be a line. I could say line CD is the segment bisector of AB. It could be another segment. It could just be segment CD, and I can just cut it off right here. It could be ray MC, I could go M to C. Ray MC could be a segment bisector. So it could be any of those things, right? It could even be a plane, possibly, in some cases. So it could be a point, a line, a segment, a ray, a plane, something that cuts that segment in half. But the key here, once again, is in order to know that it's cutting it in half, is I got to know that these two pieces are the same length or congruent to one another. How they're cut or what cuts them doesn't really matter. The fact that they are the equal distance, then that's the most important thing. Okay, we've got a skateboard down here. XT is 39.9. Okay, and it's kind of hard to see this, but there are two markings on that picture. Okay, so XT is 39.9. Find XY. Okay, here's where you kind of have to be careful. Okay, there's a lot of things in here that people will get thrown off with. Okay, the first thing that some people might do is they'll immediately say, oh, it's 39.9, because we don't really pay attention to what exactly it is that we're trying to find. What length would also be 39.9? Okay, which would be what? What do we call it? TY. Yep. So this would also be 39.9. Okay, and so if it said find the length of TY or find TY, that would be it, but it's asking me to find XY. Okay, and so XY over here is that whole segment. Well, what would I need to do to find that whole segment? Add them up. Yep. So we could either go 39.9 plus 39.9, or we could just do 39.9 times 2. Either way. And that would be 79.8. And because this was centimeters, then this would also be centimeters. Okay, VW here is a segment, okay? Goes from V, it goes to W. And I can tell right now that VM and MW are congruent because of the marking. What is splitting that segment in half? What kind of geometric figure is splitting that segment? A ray, okay? What would we call this ray? What'd you say? Oh, what would we name that ray that's split? What would be a name?
Would it just be an or would it? No.
You got to use 2 letters.
Oh,
MN. And we have to start with, we have to always start with the endpoint. So we're going to go MN. Okay. Symbols. Be careful of your symbols, right? MN, we want the arrow on the point that it goes through. M has to be my starting point because that's where the ray starts at. Okay, so we go MN, goes through N. That is what we call the segment bisector. In this case, it's a ray. We just determined that these two pieces are congruent, so now we're trying to find VM. Okay, we know that VM is equal to MW. Those two pieces are marked the same, so we know that they are the same length. So we're going to say VM equals MW. VM is 4x minus 1. MW is 3x plus 3. Those are the expressions that represent that segment. And now we have an equation to solve. Okay, there's going to be a lot of solving of equations this year in geometry. You might have thought, oh, I'm out of algebra. I'm done with it, right? Nope, we're just getting started. So we're going to get x together. Subtract 3x. We're going to add 1. We get x equals 4. Okay. Now, here's the part you got to be careful of. Okay, and I keep saying that, but there are a lot of different things where what happens a lot of times is we don't focus on what it is we're actually trying to find. And here it's asking us to find VM. If it said solve for x, we'd be done, right? X equals 4, we're done. but it says solve or find VM. VM is this piece right here. We know that VM is also 4x minus 1. So I can take x equals 4, I can plug it in where the x is, and I can do 4 times 4 minus 1. So I get VM equals 15. Four times 4 is 16. 16 minus 1 is 15. Okay. Once again, here is PQ. We got this piece that's going through M right here. What kind of geometric figure is bisecting that segment? What do you think, Garrett? What kind of figure is bisecting PQ?
ML.
Okay, can we call it ML? Okay. Is M a point?
No.
It actually is. I mean, I know there's no point here, but it's where two lines are crossing, so that's a point, right?
Yeah.
So we could put a point here. So M is a point. Okay. Is L a point?
No.
No. Okay. So we can't use 2 points because do we have 2 points on this line?
What's our what?
Is there 2 points on that line?
No.
No, it's just one, right? And so in order to name a line, I can either use 2 points or I can use the lowercase letter that's next to that line. Okay? Line L. Okay? So the segment bisector is line L. Okay? So the reason we're doing that is because the segment bisector can be a lot of different things. It could be a line, a ray, a segment, a point. We have to identify what geometric figure is splitting that in half. In this case, it's line L. Okay, once again, we know PM and QM are congruent, so I'm just going to make a statement here that says PM is equal to QM. PM is 5x minus 3. It's labeled on the picture. QM is 11 minus 2x. And then we can solve it. Okay, what would be the first step that I would do to solve this equation? Add 2x to the other side, that'll work. Okay, and there's more than one way to go about this, but that would be one place to start. Okay. Okay, and I kind of like combining 2 steps into one. If you want to break it down into smaller steps, you can. 7x equals 14, we can divide by 7 and we get x equals 2. Bless you. But now it's asking me to find PQ. So PQ is the length of that whole segment, right? There is no expression that represents that entire segment. But what we know is this is half, this is half. So I got to find the length of both of those, and then I can add them together to find the whole thing. Okay? So I'm going to take 2, and I'm going to plug it in. 5 times 2 is 10 minus 3 gives me 7. Over here, 11 minus 2 times 2. 2 times 2 is 4. 11 minus 4 is 7. So the length of PQ would be 14. Each half is 7, so we do 7 plus 7. Do what?
Is this like algebra with?
You got it. It's algebra with some pictures, right? Just what you wanted to hear, because you loved algebra, right, Austin? Algebra was great. No? Okay. Midpoint formula. So what we're looking at now is if I wanted to find the midpoint on a coordinate plane. If I drew a coordinate plane up here, and I put 2 points on that coordinate plane, let's call it point A and point B, then what I want to find is I want to find the point that's halfway between A and B. Okay, and I'm just going to kind of eyeball it here, but it would be this point right here. I can't just look at that segment and say, this looks like it's about halfway. I got to have a formula. I got to have a way of actually evaluating or figuring out what that point, what that ordered pair is going to be. So first up, our answer is going to be an ordered pair here. It's going to be a point that is halfway, okay? So we're going to say that A is represented by x1, y1. B is represented by x2, y2. So it's just 2 ordered pairs. And all this means is first x, first y, second x, second y. And it doesn't really matter which one's which. Okay, I could let this one be x1, y1 if I wanted to, and vice versa. So the formula looks like this. x1 plus x2 all over 2, y1 plus y2 all over 2. All that we are doing here, just so you understand this formula and don't try to make it more than it is. If I wanted to find the point that's in the middle, let's say you have 2 test grades. How would I find the average of 2 test grades?
Add them together and divide by 2.
You got it, right? If I have a 70 and a 90, 70 plus 90 divided by 2 would be 80, okay? 80 would be the score that's right in the middle. So that's all that we're doing here is we're finding the average of the x's, we're finding the average of the y's, and my answer is an ordered pair. Okay.
But can you like put them all together and like cancel them out? Like I go something like.
Could, except the problem is that your points are at, it's not like a number line where it's like a cross. It's at an angle like this. And so trying to like meet in the middle would be kind of hard to do because you can't really count at an angle like that. If it was on a number line, you bet you could do that. Okay. So that's what would make it hard to do that. All right, so for this one here, and you don't have to draw a picture on all of these, but I'm going to draw a picture here just so we get kind of a visual of what's going on. 1, -3, and 4, 2. Okay, so we're going to add our x's together. 1 plus 4 divided by 2. Then we're going to add our y's together. -3 plus 2 divided by 2. 1 plus 4 is 5. Divided by 2 would be 5/2. -3 plus 2 is -1. Be -1/2. Okay. Our answer is not always going to be a nice whole number. It'd be nice if it was, right? If we never ended up with fractions and decimals, you guys would probably be pretty happy because we don't have any fractions and decimals, right? But unfortunately, we do have fractions. We do have decimals we have to deal with. 5/2 is really 2.5. If you wanted to write it as a decimal, you can, but I'm just going to leave it as a fraction. So 2.5 means I'm going to go over 2 and about 1/2, and then I'm going to go down 1/2. So if I go over 2 1/2 and down 1/2, then that looks to be about right, okay? And what that does is that just kind of gives me verification that it looks right, okay? And if it doesn't look right, maybe I did some math wrong. Do you have to graph it? Not necessarily, but sometimes it's not a bad idea, and then we can kind of look and see, does it work? Okay, so that would be our answer. Just an ordered pair, okay? And not always a nice ordered pair at that. Okay, part B. As you read through this one, it's a little bit different problem, okay? Because M is at 2, 1, J is at 1, 4. Okay, if I were to connect J to M, okay, what we have to keep in mind here is M is only halfway. Okay, M is only halfway. So J to M, we want to find the point that's on the other end. We got to find the point that's down here somewhere.
Mr. Ruder,
Yeah.
when you write like midpoint, like K equals something, do you just do point M or like point K, or like what's the symbol for midpoint?
It doesn't really have a midpoint. So if it doesn't have a point that's labeled there, M is usually the label for that.
So like I just write M?
Yeah, point M. Yep. Yeah, so like on this one up here, if I said this was my midpoint, then I would maybe just label that with an M. Yep. And it did kind of say that here, that midpoint M, that using
It
capital
was
M.
just like what was the symbol outside of M, like if it's a line or a point?
Oh yeah, no symbol. Yep, just point M. If you just have a letter, capital letter all by itself, it always means point. Okay, as I look at this one here then, we have only gone halfway. So, and I'm just kind of eyeballing it here. Here's halfway. We have another point that's down here somewhere, right? And we don't know exactly where that's at, and otherwise we'd be guessing. So we got to figure out what that would be. Now there's a couple of different ways to figure this out. I'm going to call J X1, Y1. And so here's what it's going to look like. 1 plus something divided by 2 equals the midpoint. Okay, this here is my midpoint, 2, 1. So we're going to add up the 2 endpoints divided by 2 equals the midpoint. That's one of my equations. The second equation, we're going to take 4 plus y divided by 2 equals the midpoint, which is 1. So we're trying to find the y value now. Okay? So those are my 2 equations. Those are my 2 equations. Now we got to solve it for x and for y. What are we going to do to solve for x? What would be my first step? Do what? Combine these together? Can we do that? Are they alike terms? No. Not yet, though. What do we have to do before subtracting the 1? Yeah. Multiply by 2. Okay? Because right now we're dividing by 2. So I have to multiply by 2. Yeah. So I get 1 plus x equals 4. And then I'm going to subtract 1 from both sides. get x equals 3. Okay, here's the good news is over here, we're essentially doing the same steps. Different number a little bit, but we're going to multiply by 2 first. And I get 4 plus y equals 2. And then I'm going to subtract 4. And I get y equals negative 2. So my answer here is 3, negative 2. It's going to be an ordered pair. Okay? Remember, we kind of eyeballed about where it would be. If I go over 3 and down 2, doesn't look too bad, right? Looks pretty good. Looks like that should be about where it would be. And I was just kind of estimating about where it should be. But if I go over 3, down 2, that should look about right. Okay. I'm going to show you another way to do that one here in just a second. And then you can kind of decide what makes the most sense to you. Okay, on part C, we got 2 endpoints. So that's the thing you're going to have to pay attention to on big ideas, and then eventually as we get into quizzes and tests. Are we given 2 endpoints, or are we given an endpoint and a midpoint? Okay, because those are 2 completely different problems. If I'm given 2 endpoints, then it's a little bit easier problem. x1, y1, x2, y2. Negative 4 plus negative 6 will be negative 10. Negative 10 divided by 2 would be negative 5. 3 plus 5 is 8. 8 divided by 2 is 4. I didn't draw a picture on this one. You don't necessarily have to draw a picture, okay? Sometimes if you're a visual person, drawing the picture is helpful just to see, does it look right? Does it feel right? Does it look like that point should be the midpoint between the other 2 points? All right, the last one we're going to do today, because after this is the distance formula, which we're going to do tomorrow. We did one like this on part B, but I'm going to show you a little bit different method, okay? And I kind of like this method a little bit, but you got to have a little bit of number sense in order to do this. If you like the other one where you set up the equations, then that's perfectly fine too. Sometimes I kind of like to show you different ways to get there, and then you can kind of determine which way makes more sense to you. This is my end point. This is my midpoint. Okay, so for something like this, I'm not necessarily going to put it on a coordinate plane. I'm just going to make like this big number line, okay? And I'll show you what we're going to do with this number line. We're going to put 4, 4 on one of the ends, okay? And I don't care what end you put it on, left or the right. I'm going to put it on the left just because I think that makes the most sense. I'm going to put M in the middle. We got to figure out how far do we got to move to get to this point over here. Where is the other end point going to be? Okay, so we got to do both x's and we got to do y's. We got to do them separately. So what you'll have to be able to do here is you'll have to kind of think number sense wise. Let's start with x's first. If I was going to start at 4 on a number line and I move back to negative 1, how many units would I have to move? Okay, which direction?
Left, actually.
Yeah, left, actually. And so that's why doing on a number line sometimes, like, yes, we're where I place it, but it doesn't necessarily work for both. So that might be a little confusing to some of you because we're doing that, but that's why I'm going to do this. For my x's, which is this number right here, to get over to here, we're subtracting 5. Okay? That gets me to the halfway point. So, this is my x value now. Because it is the halfway point, I got to move another 5 to the left. So if I'm at -1 and I move 5 units left, that would leave me at -6. Okay, that would be my x value. Okay, so all we're saying is, how much do I have to move to get from here to here? Is it left or right? How much left or right? And I'm going to move the same units in the same direction. Okay? Let's try the y's.
So it'd be -8.
If I go from 4 to -2, how far am I moving?
Wait, 6.
Okay, which direction?
6.
Positive or -6?
Negative.
Negative. -6, right? +4 back to a -2. I'm going back 6, left 6, down 6, however you want to say it. Okay? And then I'm going to take that same number again, and I'm going to move the same number of units in the same direction from -2. So if I'm at -2 and I subtract 6 more, that would put me at -8. That's our answer. Okay. What do you guys think? Do you like this better, or do you like doing the equation?
I like this better.
I like that one a little bit better. I mean, if you're kind of a visual, number sense kind of person, I think that one works a little bit better.
I like that one.
It's kind of up to you.